Reworking and repairing electronic assemblies. Reworking and repairing electronic assemblies involves the process of diagnosing and correcting faults or defects in electronic components and circuits. This can include fixing issues like damaged components, soldering defects, or incorrect connections. Here's a general overview of how repairing and reworking electronic assemblies is typically done. 1. Diagnosis. Identify the problem by examining the symptoms reported or observed in the electronic assembly. This might involve visual inspection, testing with specialized equipment, and understanding the circuit's behavior. 2. Gather information. Collect any available documentation, such as schematics, datasheets, and assembly drawings for the electronic components and circuitry you're working on. This will help you understand the expected behavior and correct connections. 3. Tools and equipment. Ensure you have the necessary tools and equipment for the repair and rework process. This may include soldering irons, desoldering tools, multimeters, soldering flux, solder wick, hot air rework stations, magnifying tools, and anti-static precautions. 4. Component replacement. If a faulty component is identified, carefully remove the defective part using appropriate desoldering techniques. This could involve using a desoldering wick, a solder sucker, or hot air to melt the solder and remove the component. After removing the old component, clean the pads and the surrounding area. Ensure proper alignment and orientation. 5. Component installation. Place a new component of the exact specification onto the cleaned pads. Apply soldering flux to the pads to ensure a good solder joint. 6. Soldering. Using a soldering iron, simultaneously apply heat to the solder pads and the component leads. Apply solder wire to the joint, allowing it to melt and flow evenly onto the pad, forming a secure connection. Avoid overheating to prevent damage to the component. 7. Inspection. Visually inspect the solder joints to ensure they are properly formed, without bridges, solder connecting adjacent pads, cold joints, dull and grainy appearance, or excess solder. 8. Testing. Once the rework is completed, test the repaired assembly to ensure that the initial issue has been resolved and no new problems have been introduced. 9. Documentation. Record the repair details, including the problem, the steps taken, and the replaced components. This documentation can be valuable for future reference and quality control. 10. Quality control. Perform a final inspection and possibly functional testing to verify that the assembly functions as intended after the repair. 11. Preventive measures. Identify the problem's root cause to prevent future similar issues. This could involve improving the design, production process, or environmental conditions. It's important to note that working with electronic assemblies requires skill and experience, especially when dealing with delicate components. If you're unfamiliar with the process, it might be wise to seek guidance from experienced technicians or professionals in the field. Additionally, practicing proper ESD, electrostatic discharge, protection and safety measures is crucial to avoid damaging sensitive components during the repair and rework process. If you want to learn more about rework and repair of electronic assemblies, the IPC 7711-7721st Certified IPC Application Specialist, CISS, is a certification program offered by IPC. This program trains individuals to properly apply the IPC 7711-7721st standard for electronic assembly rework and repair. Participants who complete the program and pass the certification exam demonstrate their proficiency in applying the techniques and guidelines outlined in the standard. Thanks for watching. For more information, contact us. www.anzurusa.com